Yeah, so everybody, welcome to Codeforces. Today we have Div3 contest, which should have happened yesterday, but yeah, it got delayed because of some issues on their side. So, but today we'll have it. Okay. I believe it has like 7 problems or something. If I'm not mistaken, then we can just go to all problems like this. Yeah. And we can also open submit sync immediately. Problem A, do not be distracted. Sorry, I have to clear my throat a bit. Okay. So Polycarp has 26 tasks. Each task is designated, okay, by a capital letter of the Latin alphabet. The teacher asked Polycarp to solve tasks in the following way. If Polycarp began to solve some task, then he must solve it to the end without being distracted by another task. Okay, distraction. After switching to another task, Polycarp cannot return to the previous task. Okay, that makes sense because he already finished it. So why would he come back? Polycarp can only solve one task during the day. Every day he wrote down the task he solved. Now the teacher wants to know if Polycarp followed his advice. Okay. Sounds strange, actually. Sounds like we can do the following idea. First, of course, we have to read the test cases. Once we did it, like we don't mind if he has like consecutive groups of days when he was solving the same task, because it's fine. It's what we wanted him to do. What we care about is what happens and whether or not he has 2 days on which he was solving the same tasks, but which are not in the same group. Makes sense. So how to do it? I'm going to define a function compress, which will take in a string and return another string, and that string will only contain one character in each consecutive group, so that we don't have to. That's because it's convenient, right? So how do we do it? We create a new variable t. Then we can loop over all characters in string s, and if our output string is empty, or our character is new, is different from the last character of t, which I believe we can access like this. Potentially not, but let's hope so. Then we want to append that character to our string, and then we want to return the string. So now we have compressed strings, right? What we're going to do now is let's say actually tt should be fine. I mean, this is a separate scope, so okay. We want to compress the string s. And now what we want to check is that after we compress, there are no 2 occurrences of the same letter which are not consecutive. which basically means that all letters have to be unique, right? So what we can do is check if the length of the string is the same as length of a set of characters. I'm going to do it like that. So we create a set of letters that are in the string. Then we can take the size of it, we compare to unsigned integers, seems reasonable, and then we output either yes or no, if he didn't follow our advice. I mean, sounds reasonable. Probably you can do it like in place and stuff, but you don't have to, not really have to. The answers seem correct, so we can just go ahead and submit our code. We have some stupid edge test cases. No, I mean, we don't even have empty strings, don't have anything strange. So GCC, problem A should be fine, but let's wait if the queue is not very long. Looks like it is actually. Okay, maybe it's better just keep reading problems and we'll come back to it later. Problem B sounds like some math problem based on the length of the statement. Ordinary numbers, let's call a positive integer an ordinary if in the decimal notation all its digits are the same. For example, 1 to 99 are ordinary numbers, but 719 and 2021 are not ordinary numbers. Still in the queue. For a given number n, find the number of ordinary numbers among the numbers from 1 to n. Boring. Okay, whatever. Again, we do have several test cases. N is not particularly large, so I don't think that we need to handle any sort of overflow here. And just create variable n with it. The idea is, of course, that number n has some length as a string. Pretty like for every smaller length, there are exactly 9 numbers that are ordinary. And then for the same length as n, there may or may not be like several ordinary numbers, and it depends on how large the number n is. But I'm very lazy, and because of that, we are going to do the following solution. Let me just make sure that I don't overflow anywhere. So I will just generate all numbers that are ordinary, and then I'm going to find my number at what index it should have been in that sorted array of ordinary numbers. And then we'll have what we want. At most 11, let's say. Although I don't think that we need that much. N is at most 10 to the 9th. So actually, I don't care. My max length is 9 because there will be no ordinary numbers of that kind. Now what we should do sounds like this. we should have a power of 10. That power should be computed correctly. Then no, we should just keep track of the smallest such number. So this guy will be like 111, 111, 1111, etc. And then we're going to loop over all digits that it can have, including 9. By the way, yeah, the problem A was accepted. So we just loop over all digits that this number can have. Then we push back, I don't know, D times B. Very boring, I know. Then we should inclusive from 1 to n inclusive. Is it so? Yeah, it is inclusive, so we should take upper bounds. That array. Actually, I forgot that I have that shortcut for n. And then we want to output the distance from the beginning of array to the position where we found our elements. And can even do it like this if we like one-liner things. But I will adjust several things. I want to check this test case. I assume that I want to check this test case. So this test case, and let's say this test case. So the first 6 answers are correct. Then this is one bigger than this because we included 111. And then this is 81, which is correct because it has 9 digits for each length from 1 to 9. There are 9 trusted numbers up to that point. And then the one after it is basically the same answer. I just wanted to check it because it's the max input that we can have. Yeah, like if you take at 1 lower, then you're fine. Your answer is 1 less. Excuse me. Yeah. Okay, then I believe we can submit this problem as well. This is not the fastest way to do it, but it is just a solution that should work. Like you can count by digits explicitly, but I don't want to do that. I would rather upper bound. Because we create our array in sorted order, the upper bound works correctly. And apparently the queue is still long, so we are not getting any verdicts anytime soon. Okay, let's read problem C. Problem C is not adjacent matrix. We will consider the numbers A and B as adjacent if they differ by exactly 1. Okay, so number is not adjacent to itself. Good. We'll consider cells of a square matrix n times n as adjacent if they have a common side. That's it. If for cell, okay. For a given number n, construct a square matrix n times n such that each number occurs in this matrix exactly once. If the numbers are adjacent, if the cells are adjacent, the numbers must not be adjacent. Print the -1 if the answer does not exist. Okay, this is a construction problem. Well, Wait, how is it possible for not to exist? Two, four, one. Oh, actually, that makes sense. Like 2 by 2 matrix is too small. So no matter how you create your 2 by 2 matrix, not have 4 and 4 adjacent to 2 both ways. Okay, but for every larger matrix, I believe there is a solution. So let us just, okay. Oof. In such problems, it is good to spend some time arriving at the best possible construction that you're like 100% sure that it will work, because like in this particular case, there may be not that many strange tests, but why would you want to like have a bad construction that may fail some special cases? No, we want to very calmly arrive at something very boring, yet something that will always work. So we want adjacent cells to have non-adjacent values. For each cell, we want the two numbers that are adjacent to this number not to be in the adjacent cells. Always start with 1. 1 has to go somewhere. And we just keep going with the space here. I believe I should draw the matrix so that you can see what I am doing. Let's say we are trying to fill a 5 by 5 matrix in. Doesn't really look squarish, but whatever. Yeah, I was always bad at drawing parallel lines at exactly the same distance apart. So I was going like 1, 2, 3, and probably 4, 5, and then 6, 7, no, 6, 7, 8, 9, 10, and things like that. So let's think. Clearly, every row does not contain adjacent values in adjacent cells because we go 1 by 1, 1 over 1, right? And then any cells adjacent by column will differ by exactly 5. Sounds legit. Does it work for all? Let's take something smaller, let's say 3 by 3. Again, non-squarish grid. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks reasonable. And for 2 by 2, it doesn't work because these two guys, they are adjacent. You don't have, like, you cannot skip the value of 2. I'm just going to separate the case for 1, or am I not going to? Okay. I'm going to separate the 2 case only. variable k will be the current number, then we'll have I and j, which are row and column. Or can I? Yeah, I can be more descriptive. We'll have value and we'll have row and column. But here we can do just this. We loop over row solar matrix, we loop over, actually, loop over values in each row, we print them space separated, and we don't care about the space at the end. We don't want yet another new line here. Sounds legit, apart from me forgetting that else bracket. Okay. And we want to fill rows one by one. For each row, we do the following. We say we fill columns that we go by 2. We assign the value of value and we increment the counter. Value is our counter. I believe I can clear this so that it doesn't get in the way of code. And after we did it, I will want to start. Wait, did I just? Yeah, no, I was very stupid. I said it works, but it doesn't work, right? Yeah, like 3 and 2 are adjacent. What I was thinking about. So it starts. It works from 5 onwards. Literally said that we want a very solid construction, and like 5 minutes later, I just completely do not see that my construction doesn't work. Okay, I believe that for like small values, we can actually hard code answers. Although there's most likely a very nice construction that works for all of them, but you know, why would I do that, given that they give an example answer here? We are going to print it like so. And for n equals, let me just finish that generic part, and then we'll come back to our problems with 4x4 case, which I believe also doesn't work in the algorithm in my construction. By the way, problem B got accepted, very nice. And then we have to fill 4x4 table with mentioned numbers. Start 1, 2, then we, like in my construction, we put 3 here, but we cannot do that. How would you avoid it? I would put, I don't know. Oh, actually, that sounds like a good general construction. Too bad we already implemented our stupid construction. So the idea is that we go in checkboard pattern, and because of that, like the adjacent numbers in the first half are not adjacent because they are all on the dark cells. The adjacent number in the second half are not adjacent because are not in adjacent cells because they are on the white cells, and then you only have to check like 9 and 8. but they are typically not adjacent because it's like the second cell of the first row, and this is last cell of the last row, or whatever. So I guess we can also do it like this. But here we will just use a well-known hard-coding method to get this thing up and running. Here we do want more. Let's say 10, not really 10. C inputs. Say 6, I don't know. 6. Words. Took a bit long to execute, but looks legit. Let's see, for 1, answer is 1, for 2, answer is -1, for 3, answer is 2, 9, 7, 4, 3, 3, 4, 6, 3, 1, 8, 5, then 1, 2, 3, 4, 5, 6, 7, 8. For 5, answer is 1, 2, 3, go, then 4, 5, 6, 7, 8, 9, 10. I don't really see what can go wrong with this. Like it certainly works for sizes of at least 5 because the last or pre-last element of the first row is not adjacent to the second element. And therefore, and they are like the only numbers that are adjacent in a row. And also last or pre-last element is not adjacent to the first element of the next row. So yeah, we can send this code. I believe it will work, although we are terribly slow in implementing it, but whatever. Like, it's more important to explain solutions and stuff. So maybe Q is not long now. Does it look like it? Okay, probably these same differences. We are given an array A of n integers. We want to count the number of pairs of indices ij such that I is smaller than j and ij minus ai is j minus I. What can I say? It's boring. We create a hash like this. This is rewritten. This equation is rewritten as AI. No, is it dark or is not? This is, yeah, it's boring, but in different way. So aj minus j is equal to ai minus I. Therefore, we create a hash table which will count frequency of each such expression, and then we just increment our answer whenever we encounter the same. Yes, problem C was accepted, although it took some time to execute. Probably because like we can have 100 test cases, and for each test case we want to output, we could have to output 100 squared elements, so the complexity is actually 100 to the power of 3, and this is I/O operations, which are a bit expensive. That's why running time is not instant. But here we again have several test cases. We have size. I will create array inside of the loop. To be honest, we don't even need an array. Just like, why would you use an array if you don't need one? What we don't need is an ordered or ordered map, 10 to the fifth. I have bad memories about an ordered maps, so I'll just go with this map. That's probably nothing that's here. The number of such pairs can be huge. So we better do this. Okay, we'll how do you do that? So, yeah, I just want to have a test case when the answer is huge. I'll save it to a separate file because it's a d-test. Makes sense. Now, writing your own test cases is always good. If we open the file d2, it contains just an array of integers, although I probably should append like 1 and then 1,000. Oh, it could have 200,000. My bad. Now it should have all the information we need. All right, and we can copy that to like small correctness tests and then stress tests. I said that we don't need an array because what we can do is the following. So I believe first we have to say AI current element. So we read an AI. We increment map value at AI minus I, and we don't care about i's being 1 indexed or 0 indexed because the difference, just all the differences change by 1. And then what should actually happen first is this. This counts how many pairs we've seen already, and this updates the number of pairs. Small correctness tests output correct answers, and then for the last one, I don't know exactly what we should see, but I believe it's like 200,000 choose 2. It looks like this, and it really looks like it should look. So we did not have any overflow because we are adding numbers. Adding numbers cannot overflow if the resulting type is log, I believe. Numbers are at most n, although it doesn't matter. But Yeah, I think we should trust ourselves to some extent. Is Q still long? Looks like it is. I know it should not help if you refresh, but I still want to refresh sometimes. Okay. Let's just keep reading like it's more or less standard. Yeah, you guys trust yourself sometimes, although not like very often. So okay. Oh, so we will have interactive problems, our old nemesis. Okay. It means that we want to rename our files F1 and F2, and also G, because they told us that there are 7 problems, but apparently there are 8 problems. We count subversions. Still in the queue, right? Okay. Problem E, arranging the ship. You plan the game arranging the ship. Good. The goal of this game is to make the ship line up. Makes sense. The level in this game is described by a string of length n, consisting of characters dot, which means an empty space, and star, which means a ship. In one move, we can move any ship 1 square to the left or 1 square to the right if the corresponding square exists and is empty. The game ends as soon as the ship are lined up. That's it. There should be no empty cells between any ship. This is a standard interview problem called group the ones. The idea is to move all the ship towards the median. I should just Google it like this. And it's problem E. What happened to Codeforces? For k consecutive ones, why would it? Okay, apparently, yeah, we have that harder subversion when you only want to group k consecutive ones together. No, probably should not. Maybe if it's fast, if it is faster, if we minimum swaps to group all ones together. Is it still premium? Boring. So why did it work? I forgot. No, we have all the time in the world, so we can just remind ourselves how it works. An efficient solution is to optimize by finding the subbrains above partial count. Okay, we count the number of ones. I believe we can do it better in C++ than with a for loop, but whatever. Is it just count? Yeah, boring. Okay, what do we want next? This sounds like we compute the partial sums. Who is X number of ones? Wait, is it? Oh, it's not adjacent swaps, right? Yeah, sometimes you have to be careful. But doesn't matter a lot. Adjacent swaps to group adjacent swap. Group similar characters. No. Maybe we should just use this problem with this parameter. Yeah. Now, you know, maybe you think that it's legal what we are doing here, but like for me, the best programmer is the lazy one. Because like if you know for a given fact that there is a solution to your problem somewhere, why don't you go ahead and save yourself from unnecessary errors? I don't have submissions for that problem. Oh, I do, and they actually are in C++ language. See, I'm that lazy that I forgot what my solution was. Well, 5 months passed, so it's strange. Sounds strange. So apparently we found all the positions, and then we said like we want to go towards middle. That's it. Okay. Like this code is actually looks like it's written by us because it contains SD. And numerically, it's like nobody uses this. People just write int max. Well, actually, it's a function. Okay, we'll have it like this. nums is a string. I believe here we had some speed up for that algorithm. Wait, how is that? How is that? This is quadratic solution. Oh, okay. Apparently, I was too lazy making today because it certainly looks quadratic. Yeah. Okay. I will. See, oh, there is off and solution. Cool. And it was also written before the contest, so this is legal. Vector long. 3 and 9. No. A, B. What's on? Okay, so I also forgot what is a shortcut to replace. So still we do find all occurrences of even sync be as safe as possible. Then we take the lens. For some reason, we didn't want to do it here. But I mean, you just want to cast it to integer. Here, interesting, quite a bit interesting. And we may actually need a lot of swaps. I believe quadratic number of swaps. This expression sounds like K has to be long as well. This is binomial coefficient, is it? Definitely looks somewhat similar. Here it sounds like we compute partial sums of A. Do it like this. Let me just quickly remind myself what was the idea here. We got all the positions of sheep, right? Sheep positions. Oh, it's replaced everything. Yeah, the nums should be S actually. We generate all positions of the ship. Then for some bizarre reason, we want to compute partial sums. Potentially because they are number of moves is invariant under what we were looking for, under this sum of these positions. Because if two sheep swap, one goes to the left, one goes to the right, number swap doesn't change, required to group them together. I think if we all, like we have to move them to the right easily. This expression apparently calculates the optimal way to group everyone towards the middle. Or at least I believe so. Or not towards the middle, but towards like into the range, to pack everyone into the range from I to I plus k. I think it does something like this. Okay, let's get back to our problem. We do have test cases for it, and also problem D got accepted. Good. What is it? We are grouping the sheep. Oof. Looks reasonable. I don't even know what to do. Our algorithm is linear in the input size, so it should work. Well, let's just submit. Like, I do believe that that solution works for the lead code problem. We can probably test it. Will be a bit different. Should be S, but here it should be like this, and we can submit. I do agree. Well, works very fast, so we should be covered. We're good with this. I'm interested if the queue is still long after 1 hour of the contest. Judging by how long it takes Codeforces to at least submit, probably is. I don't know, maybe everyone feels the same about this problem, that they are pretty standard. Although we wasted like 20 minutes, probably could have come up with that solution. Either way, like faster, without actually searching for it. I don't know. I believe I made everything that should be long. So I do not expect problems with this one, but again, it takes just, the queue is just too long. Okay, problem F1, guess the case 0 easy version. This is an interactive problem. This is an easy version of the problem. The difference from the hard version is that the easy version, in the easy version, t equals 1 and the number of queries is limited to 20. T T can be, okay, can be N, and the total number of queries is limited to. Okay, what happens? Let me just read the statement because the difference is not clear immediately. Polycarp is playing a computer game. In this game, an array consists of zeros and ones is hidden. An array consisting of zeros and ones is hidden. Okay. Polycarp wins if he guesses the position of the case 0 from the left t times. Okay. Polycarp can make no more than 20 queries of the following type. From L to R, find the sum of the elements in positions from L to 0 inclusive. This is an easy version of the problem. It really makes sense since t equals 1 always. Okay. To make the game more interesting, and you guess. To make the game more interesting, each guessed 0 turns into 1 and the game continues on the changed array. More formally, if the position of the case 0 was x, then after Polycarp guessed this position, the x element of this array will be replaced from 0 to 1. Of course, this feature affects something only for t equal 1. Okay. Sounds like binary search. The idea is that if the array does not change, then we can just binary search. Requires number of zeros. Well, essentially getting the sum of the subarray is the same as getting the number of zeros, right? Because the array consists of zeros and ones. So the sum is length minus number of zeros, and the number of zeros is length minus sum. Okay. So we just binary search. We don't even have to change left. For this problem, number of pairs is limited to this, and they cannot ask us to 6 times this requests in total, which is less than 20 and less than log n times this thing. Okay. So apparently we have several problems here. First problem is that we have to update the array, but I believe it's once we updated the array, the case 0, k is the same for everything, right? No, each integer, okay. So first problem is that the array changes. And second problem is that we have to reflect that information somehow in our code. And second problem is that we cannot just do everything naively. I mean, start a binary search for every key because we will run out of queries. Okay, what is G again?
No, I don't feel like solving interactive problems. Like F1 is easy, definitely. By the way, problem E got accepted and short lost now. Problem F1 is just an easy binary search. For problem F2, you have to think longer. Probably the information is reusable. Somehow. Like if the K did not change, then you could just use previously guessed 0 as left boundary for your next binary search. And probably it would finish quick enough. But then I don't really understand how to deal with cases when K decreases. And you cannot get all of them in advance because you have to output the answer to the previous query before they will give you the next. Okay, this is stupid. Maybe we'll come back to it later, but I don't feel like it. Problem G, to go or not to go. Dima overslept the alarm clock, which was supposed to raise him to school. Respect to Dima. That's the best decision in life you can make. Dima wonders if he'll have time to come to the first lesson. To do this, he needs to know the minimum time it will take him to get from home to school. The city where Dima lives is rectangular fields of n times n size. Each cell ij on this field is denoted by the number aij. The number negative ones means that passage through the cell is prohibited. Not a wall, not anything, it's just prohibited. Like, I don't know, private property. You're not welcome here. The number 0 means that the cell is free and Dima can walk through it. The number x means that the cell contains a portal with a cost of x. Okay, another boring shortest path problem on grid with portals. Well, I guess that's kind of what you expect from a deep freelance. So, a cell with a portal is also considered free. Okay, I understand that you meant free in the sense of free to walk through it, but for any portal, Dima can go to any other portal, while the time of moving from the portal ij to the portal xy corresponds to the sum of their costs aij plus axy. Interesting. In addition to moving between portals, Dima can also move between unoccupied cells adjacent to one side in time w. In particular, he can enter a cell with a portal and not use it. Initially, Dima is left, and the first three integers contain this. Wait, but is it fast enough? I always saw that you cannot. You cannot have such a large matrix. Is it a sync? Like 4 million? I'm not sure the extra works for it, but on the other hand, we don't have other options. And okay, time limit is 3 seconds, and well, here for some reason it's 4 seconds, and here it's 1 second. Well, because here you have to do a lot of synchronized input reading, by the way. You probably don't want this. Okay, the extra solution seems transparent, or is it? Or is it?
I don't see why he would use several portals. Oh, because they can be occupied. No, 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 no. I still don't understand. Like, does it make sense to use two different portals? Like, if you portal it in here, out here, in here, out here, why don't you simply go like that? Well, like there is some additional cost potentially here, and by going like this, you effectively say like, I'm not paying this, I'm not paying this, and I'm not paying this. So you only visit portals once. Yeah, I don't see a reason to visit several portals. You can just portal to use the final portal out exit that you used. That is strange. So, and of course you want to separate this sync, and we will do it, I believe, with creating a fake vertex that corresponds to like a portal dimension, whatever that is. So you pay to enter and you pay to exit it. And that's what you want. And that's literally all you want. Okay. Maybe it's interesting to someone to solve these problems. I just don't understand. Oof. I want a vertex ID to get it from row and column. N is number of rows. So it should be something like this. 1 million. Okay, yeah, think it is reasonable. In the extra we have distances n times n plus 1, where plus 1 corresponds to that portal dimension sync. We want to initialize them with something very high, like numeric. Actually, the maximum cost sounds something like 2 billions, and then search and through a grid, so 2 billions and 4 millions or something like that. No, I don't think we will ever overflow integers. 0, that's 0. And dn times n minus 1. Dn times n. Actually, it is supposed to be ID of n minus 1, n minus 1. It's not equal to infinity. If it's not equal, then I want to output. Else I want to output -1, I believe. Okay, and somewhere around here we should write our Dijkstra. because it needs such a construction. I haven't written it in a while in C++. Well, that you can push like actually, yeah, now I remember why you needed this. But here I believe that you can just leave it like that and it will deduce the type. Then in place should be our choice. ID is 0, this is 0, okay. Also pack and unpack these guys. Right, there is a function, right? Something like that. It is just std whatever. Of value modulo v, and I believe it returns the pair. Division type. No, okay. We divided by modulo number of this case. Modulo this. I'm a bit worried about the time complexity, but I don't see a better way. If you see, tell me. But I don't. I just legit don't see it. Or maybe I do. No. There should, like, based on the fact that there's only one only one portal that we can use, there should be some dynamic programming thing when we compute what is the distance, or BFS, okay. So in theory, we could run BFS from start and from end backwards. That would compute the cost it takes to get to any portal from the start and to get from any portal to the end. And then we would have to somehow efficiently understand which portal to use, but I don't want to think about the way to do it. Like Dijkstra for a million vertices is very questionable, but maybe that's why they give us 3 seconds and 500 megabytes. Anyways, we can unpack like so, and then pop from top. And then if, no, because it's like, it's vertex ID. No, it is distance and vertex ID. If, yeah, I'm starting to remember how we should write it in Dijkstra. How we should write Dijkstra. If the distance to vertex is equal to the actual distance, if vertex is equal to n times m, Oh, I also did not read anything. Okay, that's yeah. No, I was thinking for a moment, like where did I put the original matrix? Turns out that I just did not read it. Okay. If vertex is equal to n times n, then we want to have some portalish sync. Actually, what do we want? These guys can go here. We want to know the set of all portals and their corresponding costs. Portals. If value is greater than 0. Actually, I don't. Okay. Probably should just use RC. So we're getting ourselves an array of all portals together with the corresponding costs. This is the portal cell, and we want to place back something like an ID of our cell. RC. Like here we have several cases. First case is when we are in the portal cell. Then we want to loop our vertices and costs in portals. Actually, we can also for this. For neighbor and cost in portals, if cost plus distance to V is smaller than distance to neighbor, and distance to neighbor should get updated with this value. Should place a pair neighbor. No, distance to neighbor. Also want to get row and column back from our vertex. And if a row column is greater than 0, then we want to check whether like ARC plus distance to V is smaller than distance to portal cell. Call it that because I don't know why, because it's portal dimension. It's like the last letter. I don't know, and this is the last entry. You probably can come up with much better names than I can, but whatever.
I should use dv here to reduce number of processes, I believe. Errors, well, I don't know, maybe it's just all cached and my remarks don't make sense. I also might be talking very quietly. That's because I'm thinking a lot. And these two things don't go along quite well for me. That's one thing I want to do, and then this guy is like neighbors. It gets neighbors. Oof. I'm a bit worried that if this works, then we will have enough time to probably solve that, and I will have to do this, and I don't really like such a perspective. Yeah, just imagine that the contest ends immediately after you solve all the interesting problems, and then you can just chill. Neighboring row, neighboring cell, and years. No, it's like a difference in row, difference in column. Neighbor, your neighbor is actually ID. Well, if R plus dr, and this is at least 0, and R plus dr is at least 1, and current column plus difference in column is at least 0, and your current column plus difference in column is at most m, and then you can get the ID of your neighbor like this. Actually, that's a good question. That's a very good question. Probably can do it another lab before in texture. Like if the starting cell is invalid, what are we talking about? So, but here I will check that that our neighbor is reachable, so not a negative one. This checks row, this checks column, this checks cell. We get the ID of our neighbor, and it's basically the same thing. If distance to neighbor is less than v plus current distance to neighbor should just be plus dv, and Dijkstra should have this metric. I don't know, looks reasonable. I definitely did not read everything. Okay, we'll need some debugging here because it's just probably won't even compile. Oh, I did. Good stuff, good stuff. So apparently something went wrong, and we don't know exactly what. But the output was -1. Okay, this part goes to portals, if there are some. This part goes to neighbors. This part goes from portals to somewhere. Which part is wrong? Can be anything, actually. So I want there's a macro to do this in a good way, but I don't know it. Actually, if you think about this, the distance can be huge because W is huge. So we are completely wrong with our choice. And should just replace, is it like this? Control Alt and yeah, it's Control Alt Control. Interesting. So we only visited one cell. Why? I don't know. Well, technically this is ID of 0, 0. This is ID of 0, but okay. It sometimes splits things up. Not sure how much exactly. Maybe this is not our portal dimension. So, oh, but no, this part should still work.
here. Read it. No, everything should be one. Should be fine. We loop over these guys who do not change in row and column. We try to add a row and column to our guys. We read everything correctly, I believe. How much time? Okay, more than enough to debug this, unfortunately. Should just print in like v equals and v, r equals and r, something like c equals and then c. So it restored RNC correctly, but then got some sort of issues. Why? I don't know. With regards to stupid me, distance has to be greater than. Yeah, because previous two times the distance to where we were going was on the right. So I just won't roll the same sign every time. I am actually worried like a lot now about the fact that priority queue of pairs of long integers is significantly slower than priority queue of pairs of short integers. So we may have a problem here. Then we will have to implement a DFS and then something, maybe like sorting. This one we have to watch closely. Because it may very well TLE in Q. So basically Q is terrible. We have 10 pages of unjust omissions. I assume we don't have 50 pages, but still. Yeah, page 50 is tested. So how long exactly is the queue? At least several minutes, like 2 minutes. Yeah, around 2 minutes. Our solution will also take very long time when the queue gets to it because it's like terrible. Let's think if we can come up with a BFS resolve plan for this thing. Like we can clearly compute the distance from the start to every cell and then from the end to every cell. But how do we find whether we should use a portal or not? Should we use it most one? No, I don't understand. I mean, we could add for each portal, change the distance to it. Yeah, I probably know what is the BFS solution. It looks really questionable. Well, I guess it is what we will do if this submission deal is. Four million vertices is a lot for the extreme. Probably that's what it's going to tell us. No. It doesn't help if I refresh, right? But I kind of want to. Maybe it's just going to say like, no, don't use the extra when you can use a BFS. Or is it? Now I want to refresh again because it helped. Oh, if it is only one test case, then it's bad news for us because it means that they take a lot of time if it updates one by one. It is very bad. It is very, very bad. Imagine waiting for all that time and then getting TLE on test 69. It may very well happen because I feel like we no, okay. But maybe test 70 because we sort of did not what was expected of us, especially this like inline functions. I don't know how efficient they are. Maybe they are very bad and I did not know about it. Come on, how many tests do you need to test the correctness? Well, I guess this they must run like separate tests because you can't really have multiple test cases in one for this problem. Oh, okay, it finally got stuck after all these refreshes. Maybe it has like 120 test cases and we'll just wait for the eternity. I mean, for the rest of this contest. But yeah, probably what you wanted is actually a BFS solution. So you compute like regular distances to all cells and then you check if any portal can do you any better. You include the cost of the portal in its distance, but only after you did your normal BFS. So you do 2 BFS one way, another way, then you compute minimum of normal pass, then pass to the cheapest pass to a portal, and then cheapest pass from any portal to the end, something like that. And our solution is pretty slow, but it was pretty consistent at passing tests cases one by one so far. Your bets, will it get judged before the end of the contest or will it not? And if we need TLEs, will we have enough time to write the BFS solution? But honestly, this problem is crazy. Like the guys have portals, but they still have to go to school and cannot handle online learning. Stupid, what can I say? Honestly, teleportation is fine, but online learning, no. You have to go to school. Bro. I mean, many people will disagree probably with me because, of course, we all miss socialization and stuff. But some people miss it more than others. Yeah, it literally has like more than one hard test case. Maybe test case 100 is the last one. No. Joke about getting tested before the end of the contest is not a joke anymore. Like 35 minutes means that there were 25 minutes to go. So this submission is legit getting judged for 10 last minutes, including the time, the queue time, of course, but still not cool. I mean, you may say that I should have worked on a different problem in these 10 minutes, and probably I should have. Then I don't really feel like I want some. Apart from potentially F1. Like if it gets accepted, we will solve F1, but probably not F2 because we don't have enough time. 120 test cases legit. And then TLE like test 211. No, it got accepted in half the time, so. But it was getting judged for 10 minutes, okay. Terrible solution, but that's why you came to this video, right? Because you would not expect good solutions here. Okay, let's try to, actually I should not have closed this because I want to see I want to see remaining time. Okay. Okay, what is the oh, I believe it has like, yeah, okay. Yes, yes. Okay. And I'm printing R+1 and L+1 because we will have zero-based indices in our program, and says that the checker that the interactor wants are one-based. Believe this is also necessary, but why not? Oh, this should actually return something. Oops, sorry. Answer. We should read an answer and we should return. We should return r minus left plus 1 because both are included with minus a. This is a count of the rows on this interval. Probably this is, if it's bigger than t, then I should get middle, else low should get middle. And I want to say middle at that moment, probably. No, I don't have access to middle, so I want to say low. Legit took us like 5 minutes. Okay, probably it won't work, but F1 is the name of the game. Excuse me, what? Flush, flush. Compiled successfully. Okay, suppose that we read 6.1. They ask us about from 1 to 4, and hidden array is as such, so we respond with 3. We say, okay, 1, 5, we respond with 3. They say immediately 4. Why? Oh, we did not read K. the t is the number of test cases. Makes sense, makes sense. Or we still answer 3, 1, 5, we answer 3, 1, 6, we answer 4. It says 6, but it should not. Maybe it has at least then k zeros and we are. Listen, this interval has at least k zeros, so we are fine if we set high to middle. Every time you write a binary search, you can get it wrong. Three, still 3, but then it answers 4. And it should answer high, actually. All right, I forgot that I have to provide input by hand. No, it still says. Okay, just be careful here. Lowest possible value for this and for this, and if we all, okay. I want to ask how many elements from low to middle there are. How many zeros? This returns the number of zeros because this is the number of ones. This is the length of the interval because both R and L are inclusive, and this is number of ones, so the result should be the number of zeros. If the number of zeros on this interval is at least k, no, like if it's greater than k, then we don't want such high values. Our answer is surely smaller. How do we output low? Am I stupid or something? How low is 6? Low must, okay, low is 5, but we add 1 at the end, okay. So somehow we decided that low is high. But no. Actually, what is the number of zeros in each of these prefix arrays? It's 1. No, it is 0, 1, 1, 1, 2, 2. And we want to find the first 2. So it should be as follows. If the value is smaller, then we should update low, otherwise we should update high. Am I right? I no longer know if I'm right or not. 1 to 4, we have 3 ones from 1 to 5. Then it answers 4. Why would it do so? Oh wait, the value of low is never enough. The value of high is always enough. We should initialize like this. Okay. 6, 1, 2, from 1 to 3, number of ones is 2. From 1 to 4, the number of ones is 3. From now to 3, the number of, okay. At least it passes some example. Oh, it may not get judged until the end because of the queue line, right? Am I right? That would be unfortunate. I'm a bit worried about this -1 thing. But I think that this means that high should be at least 1. And therefore middle is well defined because it's at least 0. And then we can ask from 0 to middle because middle is at least 0. I am a bit worried. This may be terribly wrong. But the idea is that if we don't have enough zeros, then we definitely want to make our interval longer. And if we have enough zeros, then we can make it short. Oh, I'm actually wondering this situation with the queue is not ideal. Like if you submit, but your result, you get your result after the contest. It is questionable. Nice. Well, I mean, formally we don't have much to complain about because like it's our fault that we took it to the last minutes. Should have been solving this problem in the 10 minutes while my G was getting judged, but you can't expect that from every participant, right? Or, well, you actually you can, but it's kind of not nice of you. No, it will probably remain in the queue until the contest ends. Such a pity. Yeah, like nothing gets judged. Oh, it says system testing. So it's finished. Okay, I don't know if it's right or wrong. Like the idea is always binary search in these kinds of problems. Let's visit standings and see how terribly we did. I assume we are at least 500th place or probably lower because most people probably solved F1 before going to G. Still on the queue. Oh, everybody must be rushing to the standings now. So we are not doing a good job. Temporarily unavailable. Oh, there is no standings in the minimalistic version. Sad. Still in queue. Anyways, it's probably wrong answer or like runtime error or anything, but not accepted. Oof. Yeah, normal people just solve everything in 20 minutes. RIP. Yeah, we are terrible, like normal people just solve everything. Okay. I don't even know if I should release a screencast with such a result. Probably not. Still in the queue. Yeah, because 2000 people solved this problem. And then like 300 solved this and 300 solved this. Oof. Tough luck, tough luck. And it's also like the rules are educational, so we don't get any profit from solving hard problem over easy ones. I just want to wait until we get like a wrong answer verdict so that I can be legit sad. Still in the queue. Oh, and I have a meeting at 8, I believe, so probably will have to go. Oh, it's running. No, it got accepted. Okay. So where does it put us? Probably somewhere terrible, but still. Meh, I don't know, man. Like, well, one thing that is good about that contest is that we ran out of time exactly at the moment after we solved all interesting problems, or at least all not terrible problems, because this one is actually interesting. I have to think about it. I don't know. I will probably release this thing as is, or oh, we can just look at the submissions, right? What am I talking about? We can just look at the correct submissions of smart people. I hope it's not like super long. I had ideas about Fenwick tree to maintain the changes, but I don't really understand how to, but I don't fully understand how to use it. Really, you needed a No, I don't believe that you needed asymmetry for this one. Oof. That. While test cases get to 0. We get is this. It's A squares. Oh, is it? I believe you can do the same thing with the family tree and you will be fine, no? So the thing is that we I don't fully understand. It feels like we just assume that a lot of our queries overlap. Yeah, like segment tree actually produces a decomposition of every segment into smaller ones, right? And we just assume that a lot of these segments overlap and then everything works. I don't fully understand. Wait, second thread should be coded in Kotlin. What is this Java submission? Yeah, you can do it with bit, right? Because bit is Fenwick tree. Okay, we should have just invested more time into this problem. But yeah, like it sounds like the idea is to store previous answers, then after we found 0, efficiently update the results by saying that this 0 is now 1, so all answers should change to the segments that include this element, which is logarithmic number of segments in both cases. And then we just keep doing our thing, and we just assume that a lot of segments overlap, because why not? Although I don't have a formal proof that it will work. Sad. Okay, I believe this is still not a very bad result. So thanks for watching and see you next time around, which I don't know what it will be. We should probably check the list of contests, upcoming contests. What time is it? Okay, I have 15 more minutes to stay with you guys. Friday we have May challenge starts, but I cannot really make videos on it. What do you mean rated for div 2 and div 3? Of course, Saturday we have AdCoder, and apparently, on Friday we have another Codeforces round, which is div 2. I will probably participate in this one as well. It is longer than usual. So yeah, maybe tomorrow I will just absolve something because we don't have any contests here. But I'm really interested why this thing is not rated for D1. Interesting. I don't know why it is not rated. Maybe there was some post on Discuss explaining this, but actually if this is not rated, then I don't have time for short contests. Is there anything left from Gotcha? I don't really know why I include this part in this video. That's if you don't feel interested in Gotcha. You're not logged. I can very well believe that. Sorry, something went wrong. I cannot log in with Facebook or what? Error pages, I saw you around. But I logged in. Bruh, got chef in one word. I will participate in this. I don't care about it. Makes sense. I cannot click on it. Oh, okay, now I can. Very true. Also true. Low hard problems, man. Last time I couldn't solve like half of them. You're saying they're low on hard problems. What the? Yeah, but that's like exactly the opposite. So like, why do you keep it rated for lower rated people? I don't know. No, good quality is definitely correct description. No, it's definitely okay. I just imagine things that I want to see. Yeah. That's exactly what I thought. True. Well, that's kind of explains it, but not really. Yeah, but like the problem with lunchtime and cook off is that it's unstable often, or at least it was, and I don't feel confident about it getting getting stable anytime soon. Okay, so tomorrow most likely I will see you with some of solving, and on Friday I will see you with Codeforces round, leave to round, and on the weekend we have the full package of contests, ABCs and Lit Code Weeklies, and I believe ARC also on Sunday. So yeah, see you soon, guys. Thanks for watching. I hope you got something valuable from our solutions, although these were very terrible and took a lot to implement. Bye-bye. Oh, also, how do you like the islands? Should I keep them or should we just more, I don't know. Serious? I don't know. I can't be serious about such contests, so see you all later.